Thank you so much, Dr. Rachata Ausavarungnirun. He's a product planning lead from MangoBoost. Thanks for joining us at AI Evolution. Maybe we can jumpstart on the research aspects, and also you coming from a research lab to the enterprise. Can you tell us a little bit more about the transition from academia to the leading a product planning at MangoBoost? What actually drew you from this academia research to practical AI infrastructure solutions?
Sure. And first of all, it's a pleasure to be here, right? So, the transitioning actually went really smoothly because basically, if you look at my background research, I've been working on GPU architecture, how to design a GPU, how to design and address basically system bottlenecks that has to do with whatever is getting run on a GPU, which nowadays is machine learning application and AI applications, right? So these allow me to basically take what I know and what I've said so far, right, from the research point of view and apply them into the product, which is really, really interesting because MangoBoost by its own right, is a deep tech startup which actually transitioned from a lot of research projects done at the Seoul National University to address many of the system bottleneck as well. So whatever they do is actually aligned with what I do. So in that sense, I was able to actually basically take what I know from research, right, and then allow me to put whatever I know into the product to make more impact even. So it's really, really great.
Yeah, that sounds good. And also in terms of the research itself, right? You must have very specific research breakthrough that happened, right, at MangoBoost. How would you turn that into a product for your startup? Yeah.
Sure. So that's actually is a great question, right? So a lot of research nowadays in architecture and hardware, many of them would talk about things like hardware offloading. What it means is basically, let's say you need to maintain or run something. Most of the time, you rely on either the CPU to run it or a GPU to run it. Hardware offloading basically means that, hey, instead of having the CPU running this managerial task, like move the data around, why don't we put the compute next to where the data is and move them, right? So in that sense, right, some of our products, for example, our GPU boost, they're the RDMA solutions, right? It's a DPU that allow you to actually connect to GPU and let them talk to each other through a direct communication. We also have products that do storage offloading in a sense that you can actually have a remote storage, right? Like think network storage, but it offload what CPU has to do. So in that way, you can actually connect more SSD inside this remote storage, and you can have like petabyte scale storage for your enterprise workload. And we also have the initiator solution. Basically, what it allows you to do is from your server, you can talk to this remote storage, but not as a remote storage, more like a local storage. So it's easier to use and faster as well. So many of these techniques allow you to actually get better performance, lower the cost. And these actually are all coming from research.
Oh, that's really cool. I mean, as I was doing research as well. This one is really practical, turning research into industry that is very valuable. And also, if you can go into a little bit more details, if some of the enterprise leaders are evaluating the technology, right, they should compare between traditional CPU GPU scaling methods and also you guys DPUs, right? What are the fundamental differences between the two?
Great. Okay, that's actually another great question as well, right? So let's say I look at enterprise. I would use actually SCB as an example, right? You have your own model that you fine tune, and when you fine tune, right, you actually need a lot of GPUs to talk to each other, right? So what our DPU can do is actually complementary to the CPU and GPU execution, like the way to execute things, in the way that you can scale up and scale out better. What it means is let's say your fine-tuning task or even inference task, you want to have what I mean by inference is basically you look at things like ChatGPT or like Llama, right? You want to actually use the chatbot or you want to use your LLM models. You actually in many cases you need to have many GPUs talk to each other or sometimes you need a lot of memory for your GPU because the model that is released nowadays, it doesn't fit within a single GPU. It needs more memory. Scaling up allow you to fit the model, and scaling out allows you basically connect multiple GPUs together. And our DPU solution is basically designed to tackle that problem. So as an enterprise leader, right, you would look into how to do this cheaply, right? Because obviously you want to minimize the cost and you want to make sure you still get the performance because at the end of the day, you need to serve your customer. So those are the two key things you would look into. And that is why many like nowadays you would see like high performance RDMA and NIC to allow GPU to talk to each other, or a DPU where you can think of it as basically allow GPU to talk to each other, but also more things because it's more programmable and more flexible. So you can actually use those programmability and customizability to accelerate, to offload things to hardware even more.
That's cool. That sounds really like a lot of cool stuff going on over there. And also, like recently, you guys just like winning the ML performance inference, right? The benchmarks, right? So this one, I think you use Mango LN Boost software, and then on a very specific chip from AMD MI300X GPUs. So what does this record-breaking means to like like a layperson or like people so like from like enterprises who actually running on a large-scale AI workloads?
Sure. So the first thing I want to add on that, right? So the MI200X result, those are from MLPerf Inference 5.0. That was in March. We actually have a newer result this past month, actually, in MLPerf Inference 5.1. And what we do again is we had another multiple first ever, right? So in this time, we are actually the first ever to mix two types of GPU together in a single system. So in this case, you have AMD's MI325X, right? And you also have AMD MI300X, the older GPU, in the same system. And we used it together to serve inference workloads. So basically serve your chatbot, if you will, right? With this heterogeneous with these systems are called heterogeneous systems because it makes two different architecture together, right? Two different GPU generation together you can actually get even more performance and we see basically linearly scale results, which means that I add more GPU, I expect 2x, I got 2x, right? That allow us to actually get again break another record. We are again the first ever performance on Llama 270 billion. And you might have noticed Llama 270 billion is old, right? The reason we actually focus on this particular workload in MLPerf is because it's the workload that everyone submit to. It's like if you want to benchmark in MLPerf, that's one of the most popular ones. We also have our MangoBoost software working on many other models, including Llama 4 Maverick and Llama 4 Scout, and even things like multimodal text vision like a Gwen 2.5 vision model, right? So again, the key takeaway from this result is, first of all, let's say you're an enterprise, right? You bought a generation of GPU, and you see how GPU evolve these days. Every single year, there's a new GPU coming out, right? So let's say you buy one generation of the GPU, then in the next few years, you need to scale, right? You basically need to make a purchase decision. You want to buy more GPU, now you can actually buy a newer GPU, add to your cluster, and use our software to basically manage this heterogeneous cluster, and you see the linear performance scaling. Which means that you do not have to worry too much about, okay, I have this old GPU sitting here, I have another newer GPU sitting here. How do I make sure they work together well? We handle that, right? So basically at MangoBoost, we are not just a hardware company, we are a full stack solution company. So this way, right, with the newer hardware and older hardware, our software and with the full stack optimization, it can squeeze out performance of every single thing you have on your hardware so that you can get lower cost and still high performance.
That's really good because you just talk about cost. I see that you guys also claim that like throughout these DPU accelerators, you can save up to like about 95% CPU reduction, right? And then what does this mean if you were to translate that into like, cost saving or like the efficiency of the infrastructure?
Right. So this is more like a hardware related question, right? So when we said, right, is allow us to offload 95% of CPU, it basically means that let's imagine, right, you run a computer and you plug in a new SSD. Typically, your CPU is actually responsible together with the operating system like Windows or Linux or Mac OS, right, to manage your hardware. So CPU spend some time of their clock cycle trying to manage your SSD, making sure they function, making sure they operate at high performance. The problem with AI workload is you don't use your SSD typically like a typical SSD where you store for file and you most of the time forgot about it, right? You actually actively use your SSD to do many things like checkpointing, right? When you do fine tune, you need to checkpoint your model to save your progress, right? And these things demand a high performance SSD. And in that case, when you have a high performance big SSD, you spend so much of your CPU time trying to manage just your SSD. So what our DPU can do is you plug this card into your server, right? It offload what the CPU have to do, and then our our card basically allow you to. There are two things you can do, right? First of all, you can throw away the CPU completely. This solution is called JBOF, or somehow it's called just a bunch of flash. Basically, it's a storage server where there's no CPU at all. Inside is a bunch of SSD that you can put in. These are high performance SSD managed by our cards. So in this particular JBOF system, right? You first of all don't have to have the CPU in there. It's automatically managed by our JBOF solution. So basically, our card manage all the SSD and connect to your compute server. So your AI server can connect directly to this remote server and access all the SSD. This would lower the cost. So our internal evaluation, we are able to actually eliminate like 70% of your storage cost. So those are gone. And then in terms of performance, because these are hardware offloaded, it's fully hardware offloaded, which means that you also get better performance as well. So you will we saw 2 to 7 times performance improvement when you compare to a traditional JBoss solution with our DPU, our MangoBoost DPU. So that's one thing you can do. So you throw away the CPU completely, go with JBoss. The other thing you can do is, well, the CPU is now free. You can run your whatever you want to run on the CPU is available. So you can then offload this manager a task to our DPU, if you will, right? And use the CPU to run the application, the things that's important, the thing that you buy the server for, basically. So hopefully that answers your question on this particular offloading front.
Yeah,
It's more like
yeah, definitely. And a lot more information. Actually, I think a lot of people, especially from the enterprise, can actually understand more about like how would the DPU save more costs and also like making your system like much more effective as well. So coming back a little bit to during the submission of the ML perf, right? So during that time, do you guys have any like technical challenge that you actually conquer? And why do you think that like anybody else could not really find these solutions before you guys? I'm pretty sure that there are a lot of challenges happening over there. Yeah.
So let me first break down MLPerf a bit. MLPerf is basically one of the industry standard benchmark that many companies submit to, including NVIDIA and AMD, because they want to showcase their hardware, right? And the way MLPerf is run is they have multiple benchmarks. One of them is inference. Basically, it shows you if you want to run inference workload, how fast is your setup. By setup, I mean both the hardware and the software together, right? They also have training, which is focusing on basically training workload, training tasks. So these are company that do fine tuning. There's a company that would come up with a new model and release it to everyone to try, right? And then there's also ML plus storage, right? So those are more of focusing on the storage hardware. Basically, when you have to do fine tuning or training, sometimes you have to do the checkpointing. So another thing that can happen is basically things like long context, right? When you have a long context demand from a large reasoning model, this demand a lot of memory. How do you handle that using the storage system? So there are three things: inference, training, and storage. I believe we are the only company right now to submit to all three benchmarks. We submit to inference, we submit to training, and we submit to the storage, right? So I already talked about inference. And the technical challenge we have in inference is basically we have an interesting setup in our lab. We have MI300 and we have MI325. Right? What our thing is basically, hey, we have both of these hardware. How can from the enterprise point of view, if they have the same hardware, how can they leverage the older and the newer generation of architecture and work together in a single turnkey solution, right? So turnkey is a really, really big thing because as an enterprise, right, sometimes you might not have a large ML system engineering team, if you will, right? You want to focus on what's important to you. You want to build the model, you want to build a fancy AI application. So if the software is turnkey, you basically launch our software with one line and it can serve inference tasks. And then every optimization underneath is done automatically and it's full stack too. So if you compare to other solutions, right, they would focus on a particular layer. Sometimes it's networking layer, sometimes it's the ML system layer where you like tune the batch size and all those things. What we do is we take care of the whole thing down to the hardware. And the reason we can do that is because we also have DPU, so we have the hardware knowledge on what's going on in the system right now. So we can pair that up and then do the optimization, right? So that's for the inference. For fine tuning, so that's another challenge we've got because fine tuning has a lot to do with how do you complete each iteration, your fine tuning task for I mean, in ML plus training workload, right? So in that way, we have to kind of figure out how to make sure the software perform well. But on top of that, because fine tuning is a big, usually it's a big workload that involve multiple GPUs, right? We also look into how can we leverage our DPU hardware so that the DPU can talk to each other actively and get better performance. So that's another technical challenge that we are able to do, and we show a linear scaling from one GPU to two GPU to four GPU in ML for training 5.0. I think we are the only submitter that showed this for the AMD GPUs. But again, our software work with both NVIDIA and AMD GPUs. Now for storage, right? To be honest, right, we believe that our storage solution is actually one of the best in the world, if not the best right now. Because as I told you, we did an internal testing and we compared to the best DPU you can get nowadays in the market, and we see like 2 to 7x performance improvement and a lot cost saving. So what we did in MFR storage is we tried a system, and we are the you might have seen that is we are the only DPU solution, and we actually get the best performance system out of MFR storage. What it means is I have a storage system, and the way it look at performance is it basically see how many GPU I can connect to this one single system. So we are the most cost effective and the most high performing ones. And on top of that, because our system is a remote storage, right? Think of it, I have a GPU sitting here, it talks to a network storage. But from the performance we see in MFO storage, this remote storage that are far away from your GPU server actually perform as if you have an SSD on your GPU server. It get that performance. Basically, it's the best performance you can get.
Yeah, thanks. That's really insightful, and then like sounds exciting to actually be at that spot, right? Looking now at sort of like the landscape of the industries or like the enterprise, do you notice any emerging patterns for like workloads in the AI market and even beyond? If you have any suggestions, right, that you can spread it out for us, like what are the patterns that we should look out?
Oh, that's a great question. That's a great question, actually, because if you look at 2024 and compare to 2025, you see a big changes, right? You see new model like DeepSeek, you see new model like Llama, where they utilize this large reasoning model to get your answer. You see things like mixture expert. You see long context. Long context means that when you put in the input for your chat GPT or like your I guess LM like a large language model, your input is really long. It can be a file. It can be now like a GitHub source repository that consists of multiple files. These are long contexts, right? The problem with these large model with long context is it demand a lot more on the not compute, the memory. The reason behind that is when you have long context, right, your KV cache size, basic KV cache is an optimization that is done nowadays to make sure when you generate the output for your input prompt, right, it has this, I guess, if you will, like a cheat sheet where it generates if the input is this, here some quick cheat sheet to respond that has been pre-computed, right? So the size of KV cache is really big and it's big enough that it does not fit in a single GPU. And even with multiple GPUs together, somehow it doesn't fit, right? So I see the trend where you need to scale up much better. Scale up means that when I have a GPU, how much memory do I see? How much storage do I see? Right? Is a scale up to the memory and storage. So you need that high capacity memory to be much bigger. You also need the storage system to be really high performance because now you need this large terabytes or petabyte storage for your KV cache or things like RAG, right? RAG demands you build a vector database inside, I guess, your corpus of knowledge, right? So that when you look up your when you have a prompt and you look up your knowledge in a RAG database, these can be really big as well because it can be like companies' data inside this database. And there's already been studies show that the size of this vector database when you convert to an embedding table is really big. It's actually it can be like 5 to 10x bigger than a raw file from your company point of view, right? So you need this scale up and scale out capability. But again, right, from the enterprise point of view, you want to minimize the cost. Right. So this is a balance between how do I get high performance at low cost. And the way I see the landscape again in 2025 it's not just about I have a really fancy GPU that can run really quickly anymore. It's actually I need a really good compute. It can be a GPU, it can be accelerator. So there's many new startups that also look into how do I build hardware specifically to serve inference, right? So how do I leverage this and get the most out of your system? With the amount of memory I got, how do I scale out? How do I scale up? Now, another thing that I see interesting is you also have things like mixture of expert and agentic AI. If you look at agentic AI workload, for example, right, it consists of multiple models working together. Some of these are small models, some of these are large models. They are good at different good to be run on different GPU. So heterogeneity come into play. I have GPUs that work well for a small model. I have a more expensive large cluster of GPU for large model. So you want to actually balance those out as well. That's another interesting trend that I see. So that's basically kind of the I guess the trend for this year compared to last year. And I expect this trend to probably continue.
Right. With all these trends, I think that would actually help, like, enterprise quite a lot if you can, like, have, this DPU to accelerating, and also scaling up and scaling out as well, right? And also with the rack problems and agentic problems that we have to utilize all of our resource. Like, it seems like, all of the workload seems to be exponentially growth, right? But for Mango's Boost visions on, what do you see that you guys gonna position yourself, or like in terms of like the workloads, what do you envision yourself as?
So we actually envision ours because we both have a strong software and hardware team. Like by software, I meant the system software, right? So we want to actually provide a full stack solution, not just hey, we have a DPU, but something along the line of we have a turnkey solution for enterprises. If you use our software, it leverage not just the software optimization that we know, but all the hardware optimization, all the hardware offloading that can come from our GPU together, right? So from the enterprise point of view, you will see a simple solution that is cost effective, because I think one of the most important thing in ML serving nowadays is cost, right? So it should be more cost effective. On top of that, it should be working with many different type of models and many different types of GPUs. Heterogeneity is going to come into play. I want to be able to actually assign the tasks that work best to the hardware, and that's what we are looking forward to do at MangoBoost. Actually, we have many of these solutions, and hopefully these new features will be available for the customer soon, right? As I mentioned earlier, we have ML plus inference already that show heterogeneity, and we can support that. Um, we also have the full, well, we have a team to work on both the hardware and the software front, so we have a good integration. And we also, one thing that I would note here is we also have a virtual demo for if, let's say, your enterprise interested in our solution. I believe we can provide a link in this as follow-up to this talk, but we have a virtual demo where if you're interested, you can sign up and try this on your own. So it's actually set up in our lab, and you can log in and try to run this AI solution as well. Yeah.
Yeah, so that's actually come to my last question. If the enterprise at least to be really interested in you guys solutions, how would they actually get engaged with you guys? And also, what are the exciting development that you keep up your sleeves, maybe that we should look out for that's coming from MangoBoost?
Sure. Yes. So first question, right? The contacts, right? So obviously on the website we have the contact form. We also have the sign up form for the virtual demo. So those are the like a classical way to contact you. Also, you feel free to contact me on LinkedIn as well, because you can always reach out to me, and that way I can basically connect you to the right people, especially if you want to partner up with us, or you want to evaluate certain use case relevant to your use. So we are open to that. In terms of new features, hopefully that will you can try, right? So again, as I said, we want to have a solution that's full stack, right? So we are gonna have a tighter integration between the software and the hardware, and we want to be able to scale out, scale up based on your demand and based on whatever model you want to run and based on whatever GPU that you have. And that way, right, any offloading benefit that comes from our DPU can be realized easily. So it's not just realized high performance used from the enterprise point, right? It should be easy. These should be seamlessly integrated to your team. So that's some of the new features we are excited to hopefully share with all the customer in the near future, if you will, right? Um, so those are what we are kind of looking excited about right now, actually.
Yeah. So yeah, I think it's about time, but thank you so much. I think for this, I think we are excited to actually learn from you, and also looking forward to your new features coming out soon. And then all the contacts, if anyone is interested, please feel free to contact Dr. Rachata. I think that's pretty much all we have in terms of time today. Thank you so much again, Dr. Rachata.
Thank you so much. Thank you so much. Again, if you have any follow-up questions, feel free to contact me or reach out to us. We'll be happy to answer any of your questions as well. Right. Thank you. Thank you so much for your time. It's a pleasure to be here.
Pleasure. See you later. Bye.
All right. Bye.